Okay, so as we draw closer and closer to the end of the unit and end of Math 10, I'm doing this new thing. I'm going to try doing notes after the quiz. See how that goes. So today is a definitely an objective that I think most of you probably already know, but it is an important one to make sure that you understand what answers mean. Okay, having math sense is a huge deal. Okay, why am I getting what I'm getting? If you can't answer that, that means you don't know it yet. Okay, Zach, you with me here? Because we need to put that away. Now, here are 3 scenarios that we're going to be trying, because I need you to start understanding what it means to get a solution, okay? And what it means when I'm not getting a solution, and what it means when I'm getting different or many solutions. Okay, why? Why is that happening? Now, if we look at these 2 equations, A and B. Now, if you look at them the way they are right now, they have very little meaning. Just like I was talking about general form, has very little meaning when it equals 0. Okay? The only time lines have meaning to me is when they're in y equals mx plus b. Because what does the m give me? Slope. What does the b give me? Y-intercept, right? Like, that's good stuff, right? That I could visualize a line if you give me those 2 things. So let's get them to be y equals. So let's take the first one, which is 2x plus y equals 3. I want it y equals, so I'm going to minus 2x. And I will get y equals negative 2x plus 3. Now in the second one, I want to do y minus 8 equals negative 2x. I will add 8. I will get y equals negative 2x plus 8. Okay, now if I get my second best friend out here and I put in negative 2x plus 3 and I get negative 2x plus 8, I get that. If I go to find an answer, second trace 5, enter, enter, enter. Get an error. Can somebody explain to me why I'm getting an error, please? Hisham? Okay, but by looking at my calculator, I don't know if they're parallel lines. Like, they could be off by 1 degree and meet somewhere. Hisham? Why are they parallel lines? Just by looking at it? The slopes are identical, right? And that's math sense. If you don't know what you should be getting before you get to your calculator, chances are whatever you get is what you'll get, and you'll be like, yep, this makes sense. Now, I'm going to take a screenshot here. Okay, calculator go away. Okay, so this is what I'm getting. Now, by looking at this, what do you think the y-intercepts are? 3 and 8. How would you find the next point? Down to right 1. So you'd go down to right 1. Right? Down to right 1. So, how many solutions do parallel lines have? Okay, so parallel lines will have no solutions. What is synonymous with the word solution? No, not in this case. Yes, intersect. Not intersect, not intercept, intersect, right? Where those two lines intersect, okay? Because B/C, that's what that means, no intersection. Now, if I was to actually what if I had in this case, I would have 2x plus y equals 3. That's this one. Now this one, I want to get this into the same form. So I'm going to add 2x. And I'm going to add 8 to both sides. And I will get 2x plus y equals 8. Okay, so let's say I'm given those two questions. It says, use elimination and solve. Well, this one, I'm going to multiply by -1. Right? So I'm going to do that so I can add them, right? Because I like to add. What do I get? That's gone, that's gone. Like, what equals -5? I get 0 equals -5. Now, if you have math sense, you're going, either I did my work wrong or there is no solution. You're not panicking at this point. Right? Obviously, you have to understand when I'm not getting an answer. And are there times will you not get an answer? Here's the scenario. When you have two parallel lines. Both my x's and my y's cancel. Okay? So I need you to look at all of these things together. They both have the same slopes. Therefore, they are parallel. Therefore, they will have no solutions, because solutions mean intersections. And what if I had it set up like this and I get 0 equal -5? I must have done something wrong. Or do you have the confidence to go, oh, I bet you that's parallel lines. I'm going to check it another way. I'm going to put them both into y equals, see if they have the same slope. Okay? This is stuff you better get on a study sheet. Okay? Now, this one here. X plus y equals 3. So let's get these both to y equals. X plus y equals 3 minus x, y equals -1x plus 3. Next one. I need to, I'll write it down first. 2x plus 2y equals 6. I've got a minus 2x, right? Hopefully this is review for you. You're not going, what is he doing? Okay. Then what do I got to do? Divide by, on everybody, y equals -1x plus 3. No, always reduce. Always reduce, right? You're never going to see it unreduced. Okay. Now, in this form, when it was given in the question, you may not have actually known that they're what? What are these two to each other? They're the same line. How many times will they intersect? Infinite times. That is what is the actual true answer. Okay? So I'm going to graph this one old school. How would I graph it? Do a little review. No. I got to graph. I got to put 3. Don't. Okay, and then where do I go? Down 1, right 1. Down 1, right 1. Down 1, right 1. Okay? Let's do a line. And the second one would be well, that's not different enough. I need to be different line. Okay, so how many times does it intersect? Infinite times. Okay, so coincident lines. Obviously you should know where the root of that is, or what word makes it, okay? What a coincident. We are the same line. Okay, you can see those two guys running into each other. So who are you? Negative 1x plus 3. You? Negative 1x plus... What? No way. Yeah. We're coincident lines. So they are called... They're overlapping. Did you ever hear that one joke? There's 2 muffins in an oven, and one muffin says to the other muffin, "Wow, is it hot in here?" And the other muffin goes, "Ah, talking muffin." You know, I actually got an email from a kid in Calgary, and he uses my math videos, and he was saying he appreciates my jokes. So someone out there does. Okay, I got this last week. He goes, I really like your jokes. So, what did one casket say to the other casket? No. No, coffins would never say that. No, they would say, so one casket say to the other casket, "Is that you, coffin?" Okay, those are like grenade jokes. You'll get it in about 7 seconds. Wait for it. Okay, so this is what we call... Ooh, I don't want that. I do not want that. Do not do a screen capture. This is called infinite solutions. Now the thing I always want to... Now, but I guess I should have went, why are they parallel lines? They're the same slope, but different y-ends. Okay? These are the same slope and the same y-end. Okay? Now, but I want you to see how it works if you're like, okay, I see how it's set up. It's set up x plus y equals 3 and 2x plus 2y equals 6. This is like screaming use elimination on me, right? Or even substitution for that matter. Well, how's that going to look in the answer? Okay, well, I'm going to take the top and I'm going to multiply everybody by -2, right? So what do we get? 0 plus 0 equals 0. So I want you to be able to see that. If you got 0 equals a number, probably parallel lines. If you got all zeros, that means everything canceled. Therefore, they're probably coincident lines, okay? So, that is when you will get no answers. That will when you get infinite answers. Now, when you graph those two, in fact, I've actually never done this before. I would be curious to see. So I want to clear both of these. I want to see what our calculator, because remember I'm trying to teach you how to use this tool for the diploma, but if I put like y equals negative x plus 3, okay, and on this one I'm going to put negative x plus 3. Now, I'm hoping at this stage you're going, hey, those are the same. I know the answer to that, but let's graph it. Zoom 6. Here's the first one. There's the second one. And now I'm going to go second, calc, 5, enter, enter, enter. Okay, now what if I go second, calc, 5, and I move my spider, enter, enter, enter. See, he stays there because he's like, I'm good where I am. This is awesome. I didn't have to move. I'm a lazy spider. This really enables me even more. Yes?
Because, like, you know how you said the spider jumps in this intersection? So because it's already sitting on top of it.
Exactly. He's a lazy spider. Why would he move? You've given him the spot. If you actually have two lines that intersect and you put him on the intersection point, when you go enter, 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 you should not see him move. Okay? So, like I've never graphed this one before on my graphing calculator because I kind of thought it was a no-brainer, same line, right? But this one would show you. Oh, here you go. They intersect everywhere or infinitely. Okay? And then the last one is the scenario that we've all been working with, and that's intersecting lines. Okay? Now we're going to do these totally like the way it's set up, elimination. Okay? I would get the negative 4 and the 6 on the other negative 6 on the other side, but anyway, they're both in what form right now? General. Yes, they are. Again, not a useful form, but nice and neat. Okay? But if I go 2x plus y minus 4 equals 0, I'm going to minus 2x to both sides, and I'm going to add 4 to both sides, and I will get y equals negative 2x plus 4. Okay, let's not even go to our graphing calculator. I am going to graph this how? Zero comma 4 and down to right 1, down to right 1, down to right 1. Okay, so that's that one. Now I'm going to go in blue, x plus 2y minus 6 equals 0. I'm going to minus x, and I'm going to add 6 minus x plus 6. So 2y equals negative x plus 6. Then I will divide by 2. Y equals, I'm going to change this to negative 1/2 x plus 3. So I will graph this by going to 3. And where will I go? Down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Okay, so my red line is this. My blue line whoa, I'm way off here. Okay. So I don't even know if this is going to be a nice one. That's where this baby comes in handy. Negative 2x plus 4 negative 1/2 x plus 3 zoom 6. Second, calc 5, enter, enter, enter. Okay, you guys know what 0.6666 is? 2/3, yep. So we got 2/3 and 2.667 is what? Should be 7/3, I think. Oh yeah, 8/3, you're right, you're right. Okay, so we got 2/3, oops, comma 8/3. Okay. Need you go away. Okay, so one solution. Is there any other scenarios? Can I have two solutions? No, not with lines. Okay, next year you will be doing like a quadratic and then a line intersecting, so that you can have two answers, you can have one answer, or you can have zero answers. Okay, so that's the stuff that I'm getting you to go to. This year, you'll have one, you'll have none, or you'll have infinite. Those are your only scenarios that are possible when you have two lines. So if you're intersecting, give me the rules of equations for intersecting lines. Yeah, but what would the equations look like? Do you have that math sense? What would the equation look like? We talked about the equations here and here. What would the equations look like to get? Yep. Yes. But what would the equation look like? Not the answers, yes? Okay, so there would be different slopes. Would the y-intercept have to be different? No. Can have the same y-intercept. In fact, that's probably the answer. If they both have the same y-intercept but different slopes, I'm guaranteeing that that's the solution. They share that point. It's given to you already, right? So, as long as it has different slopes, you will get a solution. See the other two, what were common with them? The other two scenarios, what was common? Same slopes. If the same slope, same y-intercept, infinite. Same slope, different y-intercept, parallel. So no solutions. Okay? Now let's just look at these. Let's use our math sense. How many solutions? For A. One solution. Okay? Now, B. Now we could do some work and get them both into y equals, right? But what's another thing we could do? Let's do elimination. Let's multiply the bottom by -2. Okay, so this will just be 4x plus 10y equals 30. This would be -4x minus 10y -70, right? Are you with me? So what is this side? Gone. Gone. 0 equals so these are parallel. Now if you wanted to, sorry about that, if you wanted to, you could get them both to y equals, right? And you can see, and I'm just going to speed things up. When you get into y equals, this one's y equals -2/5 x plus 3. The other one is y equals -2/5 x plus 7. Okay, these are parallel. So both of these show these are parallel, so there's no solution. Okay, how about C? What would you expect? Anyone got any advice of even how to do this one? Okay, this is a test question. Come on, you're going to see one of these. Multiple choice. One solution. Infinite solutions. No solutions. Which one? And you're like, I don't know. Eeny, meeny, miny, mo. Okay, that's your other option. What would you do?
I would start off by balance because we have all of the variables in the multiple choice.
Okay. Or I would kind of like, because some students would, see this one's kind of in a good form, right? This one I just have to minus 35x to both sides. And it's in a good form. So then I would get negative 35x plus 21y equals 42. This would be 10x minus 6y equals negative 12. Oops. Okay, you could do that. Now, here's a tip for you. If something can go into every single number on the line, you can actually reduce it. Like, do you see anything that goes into all of these? Because remember how we've always been multiplying by? You can divide too. Let's chop this down. What could we do to divide this? By 2. So what would be my first number then? 5x minus 3y. Okay, so we divided by 2. Now, maybe you've never done that before, but you can multiply everybody by 2, you can divide. Now on the second one, what can we do? Divide by 7. So I will get so how many? What are these? They're the same lines, same aka coincident lines. Now, put them y equals, you'll see they're the same line. Okay? But I thought that was a nice teaching tip to also show, you know how we've always been multiplying to make them jive? You can divide too. As long as you do it to everybody and you do it fairly, you do not change the question. Because, like I've been showing you before, 2 plus 2 equals 4. If I want to take every one of these and divide by 2, that'd be 1 plus 1 equals 2. It doesn't change. It doesn't change the trueness of the statement. Okay? And these tricks can only be done, because students will do this later. They'll get 2 plus 2. They'll just be given that. And they're like dividing by 2, and it's like 1 plus 1. And I'm like, why did you divide by 2? Remember that thing you taught us? You can only do that trick when there's an equal sign, when it's an equation. You can't do it on, because 2 plus 2, you know what that equals? 4. Okay? Will always equal 4. If you go 2 plus 2 equals 2, I'd be like, I divided each by 2. Yeah, but that's not a true statement anymore. Okay? So you cannot do that to non-equations, only equations, and equations have equal signs in them. Okay? As students learn more and more stuff, they get more and more things mixed up. And that's the biggest reason for the study sheet, to get it all organized and to be able to see it side by side. Okay? Now, D, give me the strategy you think would be the most efficient. Yes? Yes. I see this one as y equals already. That's drawing me towards bring it in. Now this one's set up for elimination, right? So I guess there's an argument to say I set up the second one for elimination, but I bet you'd be into more work. Okay? But, you know, my goal for every one of you is you have a chance to be able to do the diploma at least 3 times. right? Like you should have 3 check marks by every question before you walk out of that gym. So the first time I would do D with y equals. The second time I would do D using elimination. Now if I get the same answer, it feels pretty good. I'm going on to the next one. And I'll come back in the third way and I'll do it another way later. I'll graph them both or something. What's actually the nicer thing is when you get 2 different answers. And you know you should be getting the same answer. And you catch your mistake on the first way. Or you made a mistake on the second way and you see what you did, but you also did that wrong on question 4. So you know to go back to question 4, right? So checking things 3 different ways also helps you with other parts of the test because you verified that your way you're doing it is correct. Therefore, I'm even feeling better about question 7 because I did that way for that one. Okay? So definitely a math diploma, you have a lot of opportunities to make sure that you're getting the right answer. So since the second one is already in y equals, I'm going to take the first one, I'll make it y equals. I'm just going to write it to the side here where I have room to work. I will add 4x to both sides. 6y equals 4x plus 6. Then I will divide by 6 on everybody. Y equals 4x over 6 plus 1. Now Hisham was saying before, shouldn't I leave this as 4, 6? And that's where you'll run into a problem. Because if you're not reducing, you would not even see what? Are they the same? Yep. Okay, so this is y equals 2/3 x plus 1. Okay, so they are, oh, did I even talk about infinite solutions here? Okay, so this one, how many solutions? Infinite. Okay, this one is also infinite because they're the same line. And it is hard to watch students go like this, and they see this, and they're like, hey, different lines, one solution. And it's fast, right? They're like, whoa, right? They hand it in, and I go, what happened here? You gave away this mark. Look, Mr. Dremel, different slopes. No. And remember, I've given you ways to be able to check it, okay? When you have a little black box with buttons on it, that will do it for you, and you ignore that, because all I have to do is get out of here if they don't let me. Why will not let me? Okay, so if I go 4 divided by 6, math, enter, enter, it'll reduce it, okay? If I go like 21 divided by 7, or I shouldn't, no, that's all going to be nice, but let's go, yeah, 21 divided by 9. Then I go math, enter, enter. It'll reduce it. Okay? So we're in good shape to for everybody to get all their work done in class and then maybe get a test back if we're working well. We'll see.